Hello, I'm Shane Sexton. This is EVSP416 General Ecology Microcosm Project, November 2021. Microcosm Overview. I chose to do a terrarium microcosm due to the variety of materials that I could use that are around my current location. Ecology has been my concentration focus for my degree path, so I wanted to try to build a microcosm that would last the full 7 weeks for the experiment. Microcosms are used by ecologists to study environmental conditions and changes in a smaller controlled setting. The microcosms in this presentation never actually saw direct sunlight as they were placed in my bay window of my house and remained indoors at around a constant 20 degrees Celsius. For every microcosm pictured in this presentation, the tap water microcosm is on the left and the natural water microcosm is on the right. This also includes any autotrophs or heterotrophs that I pictured. My hypothesis. Because of the cooler temperatures, excessive rain, and damp conditions found here in southeast Alaska, the heterotrophs such as fungi and mold will probably form and spread throughout the microcosm due to being kept in a higher temperature than they're used to. The tap water microcosm will fare slightly better in regards to mold growth due to the chemicals placed in the water here, but this may limit the life of the invertebrates, if any, are in the soil. My methods and materials. The containers I used were the large cashew containers that you can find at Costco. They're approximately 780 square centimeters. I started by adding approximately 2 centimeters of small gravel from our flower bed to simulate bedrock so it would give a place for the water to drain. I then added 5 centimeters of soil that I dug up from around our blueberry bushes in our backyard. I then dug up 2 small mushrooms and placed one in each container. Around each mushroom, though, there were some small cedar seedlings that they just happened to come with. I then pried 2 pieces of tree bark that were covered in moss at the base of the trunk. I placed one of those in each container also. I finished it off by adding 4 ounces of fresh creek water in one container and 4 ounces of our regular tap water in the other before I shut the lid for the duration of the 7 weeks. Note, though, I did not seek out any invertebrates or microorganisms. I just hoped there would be some in the soil contents that I dug up and put in them. As you can see, my tap water microcosm is on the left and my natural water microcosm is on the right. These are day 1 completed, ready to go. Observations for week 1. They look good. Soil and autotrophs look settled in. Water condensation is starting to form, so the water cycle is starting to make its approach. Moisture in the soil appears balanced. It's still wet and dark at the end of 7 days. And during the week, a slug emerged from the soil in the natural water microcosm. I have not seen any life yet in the tap water one, but we've got motion in the natural. Observations for week 2. Natural light is out and about for approximately 6 hours a day. I try to rotate each microcosm so that the light hits all 4 corners. The condensation that's building up kind of impedes it, so as I rotate them, they're getting a little bit more light in. The water cycles remain constant. Condensation is starting to build up more, so that water cycle is really starting to kick in. The soil still looks moist and dark. Unfortunately, the mushroom in the natural water microcosm has died. The one in the tap water still looks pretty strong, but I don't know if its chances are good after the first one died. Autotrophs seem to be doing well in both, and very briefly a small worm appeared. I have not seen him again, but he appeared in the natural water microcosm. I still have yet to see any heterotrophs or any microorganisms moving around in the tap water. Observations for week 3. Light conditions have steadily remained the same. It's still super cloudy here in southeast Alaska. It's still about 6 hours of daylight. It's all natural, though. Water condensation is building up more steadily now, so that water cycle's in full scope now. Small roots can be seen on the outer layers of the soil along the edges of the container, so photosynthesis is starting to do its thing. The mushrooms, however, have completely disappeared. They may or may not have been feeding the small seedlings that was surrounding them, because those have actually started to grow a little bit more. The slug we found is still thriving and running around all the areas of the natural water microcosm. We've named him Augustus after the first emperor of Rome. Observations for week 4. Natural light conditions still haven't changed. Constant temperature around 20 degrees Celsius. There's really has not been any change since week 3's data collection, with maybe some more minor growth from the cedar seedlings. The root systems are still kind of showing around the side of the containers, but nothing's actually popped its head out to show us any kind of extra autotrophs that are forming in the microcosms. Observations for week 5. All conditions pretty much the same. Soil looks still really good and moist. Condensation is still moving about. Water cycle is still thriving. Small clovers have now appeared and broke through the surface of the soil, and both microcosms, actually, both the tap water and the fresh water. And I have now seen small microorganisms. They've been seen crawling around the edges of the soil along the container of the both microcosms, but yeah, and both microcosms seem to be doing well. Observations for week 6. This is starting to get a little redundant, but all conditions have remained the same. Daily condensation, soil still looks great. Both of them are performing really well. It's kind of at this point where my hypothesis seems to be defeated, because no fungus or mold has appeared in any of the microcosms on any of the materials whatsoever. So not looking good for the hypothesis, but looking really good for the microcosms. Observations for final and end of week 7. Natural light conditions have actually slightly increased due to the amount of snowfall that we've had here in Alaska. I believe the reflection from the snow has put a lot more light through our window. Temperatures, however, have gotten down closer to 11 degrees Celsius outside, so along the window's edge it's probably a little bit cooler. It has not stopped photosynthesis though. More small clovers have shown up. This is probably due to the increase in light, but things are still moving. No other changes were observed. It's been pretty constant for almost the duration of the whole 7 weeks. Hypothesis has been defeated. No fungus or mold growth, and the heterotrophs and autotrophs in both microcosms seem to be doing well, whether it was tap water or natural water. Here are some included photos of the heterotrophs that I saw after the experiment started. Again, on the left is the tap water microcosm, and on the right is the natural water. On the left, you can see one of the small microorganisms that I found in both microcosms, but I managed to get a decent picture in the tap water one. This is actually 10 times magnification, so they are tiny, but they are there. And on the right, we can see Augustus in week 5 showing his little antennae, looking great and happy in his little new home. Here are the autotrophs I captured, the new growth. Again, the left is the tap, the right is the natural. On the left, you can see some of the small clovers in the background. On the right, that is actually a brand new growth from the morning of the last day of week 7. So things are still moving. The cycle is still going. Photosynthesis is still happening. This thing is thriving on both accounts. Major findings for this experiment. I was both extremely impressed and slightly annoyed at how well both of these microcosms performed. I was impressed at how well the small ecosystem adjusted to its new enclosure and how quickly the water cycle and photosynthesis started to begin their process. I was only slightly annoyed just because of the little data that I was able to obtain from them due to both of their success rates. So the heterotrophs in both seemed to be unfazed, especially in the tap water. They came out, they were moving about. I guess the tap water didn't really have an effect on them whatsoever. Whether or not it had an effect on the fungi or mold, it remains to be seen due to the fact that the natural water didn't have any in it either. So yeah, my hypothesis was completely unsupported due to the no ecological changes with an increase in temperature or the water conditions. Also, life in the tap water seems it fared just as well as the natural. So hypothesis defeated. Course concepts. Concept 1, carrying capacity. the overabundant autotrophic resources available in both microcosms, I believe, played a big part in its ability to survive without really any change whatsoever to the ecosystem's sustainability. The microcosms could have probably sustained a lot more heterotrophs if I'd have been able to find and add them. I did not for this experiment, but I have no doubt that I probably could have added quite a few additional, and it probably wouldn't have changed the outcome. Concept 2, source energy, consumers, and producers. It was very, very little light. It was all natural, no direct sunlight whatsoever, and photosynthesis still was able to begin creating new producers for the consumers, completing the cycle and sustaining the micro ecosystem for the entire duration of the full 7 weeks. Concept 3, terrestrial biome. I'm in the temperate rainforest. This is also known as the old growth area. It's no wonder how well these autotrophs and heterotrophs survived. I mean, they're completely used to drastic changes in temperature and weather conditions, and it's prepared them for pretty much anything you can throw at them. For further research, I'm still not 100% convinced that my hypothesis is completely wrong. I do believe in order to see any kind of significant changes to either one of the microcosms, I would need to run this for probably double the amount of time. In that aspect, though, to improve the project, I probably think I would place one of the microcosms under a direct growth light to increase the temperature and the daily light source. I think that might play a bigger part on the possible fungus and mold to actually start thriving and growing. But for this experiment alone, I did not see any of that growth whatsoever. But that's what I would do if I did this again. Microcosms and in general ecology. Microcosm studies can be instrumental in the development of studies geared at understanding global ecological problems, such as things like ecosystem responses to climate change or creating management plans for biodiversity programs. The species interactions, adaptations to the environment can all be better understood on a much smaller, more manageable scale, and it can still be obtained faster and still contain reliable data. This has been a really fun experiment. This has been a really interesting class. This is my last class before I take my capstone. I really wanted this class to be my last one because ecology is my goal of bread and butter. So thank you. Hope you enjoyed the presentation, and good luck to the rest of you.